Why couldn't humanity escape the Milky Way, even with lightspeed ships? Many people think that once we have lightspeed ships, we'll have the key to crossing the universe. In reality, it's far more complicated than that. First, ask yourself, how big is the Milky Way? That's right, it's about 100,000 light years across. So even at light speed, flying from one edge of the galaxy to the other would take 100,000 years. What does that really mean? Remember, all of human civilization is only a few thousand years old. From the first writing systems to today's information age, it hasn't even been 10,000 years. 100,000 years is 10 times that. So even at light speed, the journey would outlast civilization as we know it. By then, the passengers would be dust. Even their descendants might have forgotten why they set out. Lightspeed doesn't shrink the universe. It only forces us to face the cold reality of those distances. And light speed is not some speed humans can casually reach. Einstein's relativity gives us a harsh truth. As an object approaches light speed, its mass rises sharply, and the energy required tends toward infinity. For a spacecraft with mass, reaching light speed would take more energy than the entire universe could provide. In other words, light speed is a line the universe has drawn for us. Not a ticket to freedom, but a hard limit. We often treat technology as the key to every problem. But here, it may never cross the boundary nature has set. Even if one day humanity somehow solved the energy problem and ships really could travel at light speed, another problem would appear. Time would split apart. At near light speed, time is no longer equal. The clock on the ship slows down. What does that mean? For the people on board, only a few dozen minutes might pass, while thousands of years go by in the outside world. That means lightspeed travel is, at its core, a lonely exile. The travelers may still feel the journey moving forward, but they can never stay in step with the home they left behind. By the time they reach new coordinates, Earth may already be unrecognizable. Human civilization may have vanished, or transformed into something else. Lightspeed doesn't let us conquer distance. It cuts us off from our own world. At its center lies a supermassive black hole called Sagittarius A star. With about 4 million times the mass of the Sun, every star and planet in the Milky Way moves under the pull of this gravitational core. And beyond that, the galaxy is wrapped in an enormous halo of dark matter, whose mass far outweighs all the visible stars and nebulae. That means the Milky Way's gravity is far stronger than we can easily imagine. To escape the Milky Way, you'd need an escape velocity close to the speed of light. So even with a light-speed spacecraft, you'd only just reach the threshold, not easily cross it. The Milky Way itself is a prison almost impossible to break out of. And the harsher truth is that beyond it, the universe is not some open, empty plane. Ever since Hubble revealed the red shift of galaxies, we've known that the universe is expanding, and that this expansion is speeding up. On large enough scales, galaxies are moving away from one another faster than light. For us, those galaxies have already vanished beyond our world. Their light will never reach us, and we will never catch up to them. Cosmic expansion is not just space we can travel through. It is a widening gulf, cutting us off from countless possible destinations. So even if a light-speed spacecraft broke free of the Milky Way, it would meet despair in the wider universe. Behind all of this are two even deeper mysteries: dark matter and dark energy. The Milky Way can hold its shape, and its stars can avoid being flung away for billions of years. Because dark matter exists. It is like an invisible hand holding the galaxy together. Dark energy is like an unseen wind, constantly driving the expansion of the universe. Scientists still cannot fully explain what they are, yet they firmly control the fate of the cosmos. A spacecraft cannot escape these invisible rules. What truly traps us is often not the obstacles we can see, but the unseen chains around us. Some might ask, could we find another way out? What about wormholes? In science fiction, a wormhole is a fascinating possibility. Like a bridge joining two distant ends of the universe, letting us cross in an instant a distance that should take hundreds of thousands of years. A so-called warp drive would bend space-time itself, letting a spacecraft ride a wave of space-time and move faster than light. These ideas really do appear in solutions to Einstein's equations, and science fiction has returned to them again and again. But reality is unforgiving. A wormhole might collapse in an instant and be nearly impossible to stabilize. And a warp drive could require more energy than the entire Milky Way can produce. At least for the future we can foresee, these plans remain impossible fantasies. Even if humanity achieved a technological miracle and built a light-speed spacecraft, we would still face a more practical problem: the lifespan of civilization. Interstellar travel could take tens of thousands of years, or even longer. Can any civilization really endure across that kind of time span? Human history tells us that civilizations often disappear because of exhausted resources, war, conflict, or environmental change. To ensure that a human society aboard a spacecraft could survive for thousands of generations and still hold on to its original goal is an almost impossible challenge. We might be able to build the ship, but we cannot guarantee that its passengers would not forget their mission along the way. What traps us is not only the gravity of the Milky Way, but our own fragility and brief lives. So the answer seems clear. Even with a light-speed spacecraft, humanity may still be unable to leave the Milky Way. This is not just a physics problem. It is a cage woven from natural law, cosmic evolution, and human limits. A light-speed ship would not truly set us free.